Guys, welcome back to TechDose, and in this video we will look at the find minimum time to reach last room 1 and 2 problem. We will be seeing both the problems in the exact same video because they are almost the same question. These are from Leetcode number 3341 and 3342. We will be looking at the optimal solutions. The prerequisite before seeing this solution is to watch my video on dijkstra algorithm, and this is entirely from the topic of graph. Let's now read the problem statement. In this problem, there is a dungeon with n by m rooms arranged as a grid. You are given a 2D array move time of size n by m, where the move time at ij represents the minimum time in seconds when you can start moving to that room. You start from the room 0, 0 at time t equals to 0 and can move to an adjacent room. Moving between the adjacent room takes exactly 1 second. Return the minimum time to reach the room n-1 m-1. So this 0, 0 room is the top left room and the n-1 m-1 is the bottom right corner cell, right? So two rooms are adjacent if they share a common wall, either horizontally or vertically. Now let's look at an example for better understanding. In this case, you are given a move time matrix which is of size n by m. So the counting will start from 0. So the number of rows will be n-1, number of columns will be m-1 starting from 0, right? Now the numbers here represents what is the minimum time at which you can actually start moving to that cell. So which means that let's say I am at cell number 1, 1, and if I want to move to cell number 1, 2, then I can only start to move at least when the time is 9. Below any time 9 I cannot move, but if the time is greater than 9, then I can always move. The goal here is to find the minimum time to start from 0, 0 and reach to 2, 2. That means you need to start at 0, 0 and reach to n-1, m-1. There are certain constraints that when you start at 0, 0, as mentioned in the problem, you will always start at time t equals to 0. Therefore, whatever value is written as 0, 0, it becomes insignificant, right? It is not useful because you are not moving to 0, 0. You are already present there. You will now be moving out of the 0, 0. Okay, so the number at 0, 0 has no meaning at all. Now the number of rows and columns at max are 750. So if you consider the size of the matrix, it can go to maximum 5.6 into 10 to the power of 5. So definitely an mn square algorithm is not a way to go, right? It will exceed 10 to the power of 8. We should try something linear or something in logarithmic time, right? Like n log n time. In this example, the shortest time will be taken once you move from 0, 0 to 0, 1. The time will be at 3 you started to move and you will add plus 1 to it because it takes 1 unit of time to move from one cell to the adjacent cell. So the time here is t equals to 4. If you start to move here, and when will you start? You will start only at 5. So at 5 you will start and you took 1 unit of time to jump from 0, 1 to 1, 1. So the time t equals to 6 at this point. From here if you jump, then since the time here is 4, therefore your current time is greater than 4. So you can directly jump in just one time and the time here will be 7. That is 6 plus 1. Now from here you can jump to 2, 2. And you see when should you jump? You should start jumping only when the current timer is at 7 or greater than 7. So yes, my current timer is at 7. I can jump with a plus 1 cost and the time here will be 8. If you try with any other path, then you will not get anything better than 8. Like if you had tried this path from 2 to 6, then the cost will be 6 plus 1. The time here will be 7. If you try here, then the time here will be 8. Because since t is equals to 7, which is greater than equals to 5, you can directly jump. Now if you jump from 5 to 4, the time here will be 9 because it takes 1 cost to jump, right? So you will not improve any way below this time t equals to 8, right? So the minimum cost which is taken to reach from 0, 0 to 2, 2 in this case is t equals to 8, and so 8 is our answer, right? So I hope you have understood the problem statement. Now having understood the problem statement, you may think about the BFS and dijkstra. They both are used for shortest path problems, but BFS is used when all the costs are same. Okay, here all the costs are not the same. Every cell can have different values which will define a different cost. If all the values in the cell were same, then you can go with the BFS and you can solve the problem. That is the level order traversal. But since all the costs are different, you need to apply a greedy pick. Like whatever path looks greedily optimal to you, we will try to choose that. And if you use that greedy approach where you combine BFS with the heap, then that becomes equals to your Dijkstra algorithm. So that I had already explained in my Dijkstra video. Please find the link in the description below and also in the I button. Now I hope you already know about the Dijkstra algorithm, but before looking at the dry run, let's understand about how to make the 4 directional calls in the given problem. Now, if you have read the problem, they talk about we can make the calls in the exactly 4 adjacent cell, because for any cell you will have 4 adjacent cells at maximum, right? But then you always need to have a validity check. Like for this one, you cannot make a call up and you cannot make a call to the right hand side. So there has to be a validity check for checking the bounds. That is the thing which I have implemented in the code. I'll show you. And once the indices are valid, then we need to try out all the 4 calls. That means up, right, down and left. So if I try to make calls in this order, then we can simply define a direction array, because if you just do the DFS call, then you have to write the same thing 4 times. It is not recommended. You can make a direction array. Now in this case, if you are at an index I comma j, and if you want to move up, then from row number I, you are moving up to a row number I minus 1. So your row number is decreasing by 1 time, but your column number is the same. Okay, so whatever is I comma j to this, I am adding minus 1 to the row and plus 0 to the column. So this will be defining to your row if you add direction at 0, and to your column if you add a direction at 1, then you will be going up. Similarly to this I comma j, if you add a direction at 1 and direction at 2, then you will be moving to the right hand side, because you will be staying in the same row but increasing your column by 1 value, right? And if you want to move down, then you will be adding direction at 2 and direction at 3. And if you want to move to the left, then you will be adding direction at 3 and direction at 4. So from this direction array, if you add direction at I and direction at I plus 1 to the row and column, then you will be finding the new row and the new column. Okay, so this can be included in a for loop, and by using this new row new column, you can make the same DFS call and make the 4 directional calls without having to write the DFS 4 times, right? So this I have also implemented in the code. Now let's look at a dry run. We will try to do the dry run for the first problem, and I will show you what changes do you need to make in the first one to solve for the second one. Now I will be doing it in the form of a structure where I will be defining the node, and the node here will tell me about the location. So location of a node is defined by the row and column number, and I will also be keeping track of the current time at any given node. That means if I want to find the minimum cost from 0, 0 to 2, 2, then I have to always track what is the minimum time at which I can reach to any cell I comma j, right? So that time will be contained in the time. Now this cost is for the second variant of the problem, right? So I will show you where is this cost used, but in this dry run I will not be using it. Now let's start our single source shortest path from this 0, 0. So I will be using a min heap because I want to minimize the cost. Therefore the Dijkstra will use min heap here. Now the min heap will have 3 different values, as I said, RC and time. If I start at this 0, 0, my min heap will have 0, 0, and the time t will be equals to 0, right? So this will be present in the min heap entry. Now whenever I visit a node, I will always make sure to not re-push the node into the min heap, okay, not to reprocess it again, and that is why I will keep a visited array of the same size as the given matrix, and it will be boolean type, and all of them will have a false value initially. So I'm not making the matrix. I think you can make it. I'll show you in the code as well. So initially all the values were false, and I will just mark it true, saying that this node has been visited. Okay, now from here I will try to make 4 directional call using the for loop that I had explained. Now if you try to move up, you cannot move up. It is not a valid call because the row will be less than 0, and that is not allowed. If you try to make a right call, then can you make the right call, and when can you actually make it? So the current time is 0. Okay, you will take out this node. Your current row value is equals to 0, your current column value is 0, and your current time value is also equals to 0. So when you want to make a right call, then what will be the minimum time at which you can directly reach from 0, 0 to 0, 1? It will be equals to, you can see what is the time, it is 0, right? And what is the minimum allowed time for this movement to happen? It is 3. So we have to take the maximum of this 0 and 3 and then we have to add a +1 cost for this movement to happen. The movement will start at this 3 only, right? The current time is 0, so first the current time will be decided based on the maximum of 0 comma 3, so that will be 3, and then for the movement 1 cost will be added, so that will make it 4, right? So the time t will be 4 here for 0 comma 1, and we will mark it visited, so visited will be equals to true. So we can generalize it in a formula that you take the maximum of the current time comma the move time at the new row new column, and whatever is the maximum to this you add 1 for making the jump. Okay, and now once you know about the cost to reach to 0 1 via 0 0, then we will push this into the heap, and the heap will contain row number 0, column number 1, and the new time being equals to 4. Okay, our heap will be sorted based on the time because I want to minimize the time, right? So it will be sorted based on time. I will try to make a down call. When I try that, when can I reach to this 1 comma 0 from this 0 comma 0? The current time at 0 comma 0 is 0, right? It is 0. So we will be taking the maximum of 0 comma 6, so it will be 6, right? And we can only start moving down at time 6, and to this I will add +1 cost because 1 cost will be required to move to the adjacent cell, and that will make it 7. So the time here will be equals to 7, and I will mark it as true, that means it is visited, and I will push this into the heap. So what value will be pushed? Row number 1, column number 0, and the time will be 7. Now I will try to make the left call, but this is out of bound because the column is less than 0, so I cannot make further call. So I am done processing this node 0 comma 0. Now using the min heap I will look at the next best option, and the next best option will be 0 1 4 because 4 is having the minimum cost among these 4 and 7, right? So this will be taken out and we will be at 0 comma 1. From here we will try to make 4 calls. We cannot make a call up, we will try to make a right call. This is unvisited, so we will try to visit it. So currently here my time is equals to 4 and I want to make the right call, so I will take the maximum of this 4 and 1, which will be 4, and +1 cost will be added to make this jump. So I can reach to this 0 comma 2 at time t equals to 5. Okay, and I will mark it as visited. That means this is now done. We will not reprocess it, and I will push it back into the heap. So what will be pushed? Row number 0, column number 2, and the time is 5. Okay, now we will try to make a call down. My current time is 4, so this value being 5 says that I cannot start moving before time 5. So I will take the maximum of 4 5, which is 5, and I will add +1 cost to reach down. That will make it 6 cost, right? So I can write here as time t is equals to 6, and this is also visited, and I will push it into the heap saying that I can reach to 1 1 and the time will be equals to 6. Again I will try to make a left call, but this is already visited and it will not be processed again. So I am done processing this node 0 comma 1. Now the next best option will be taken out, and if you take out the next best option, it will be 0 comma 2 comma 5. Okay, 0 comma 2 comma 5. So this option will be taken out. From here I cannot make a up call, I cannot make a right call, I can make a down call, and here the time will be equals to max of 5 comma 9, which is 9 plus 1 for making this move, so this will be 10. So I will be inserting, I can reach to 1 comma 2 with the at time equals to 10, right, via this 0 comma 2, and then I cannot make a left call because it is already visited and we are done processing it. Now I will take out the next best option, which is 116. So I'm here at 116. I cannot make an up call, I cannot make a right call because both of them are visited. I can make a down call. Here it is 4, my current time is 6. So this means that I can immediately make the move in +1 cost, and the time will be equals to 7 here, and this will be marked as visited. So this will be pushed into the heap, and I can reach to 2 comma 1 with the cost equals to 7, right? I cannot make a left call because this is already visited. Now from this heap any node can be taken out, so let's take out this 107 instead of 217. 217 could also have been taken out, right? So let's take out 107. So if you take out 107, then this node will be taken out. From here I cannot go up because that is visited, I cannot go right, it is visited. I can go down, and here the time is 5, so current time is 7, which is greater than equals to 5, so I can immediately make the jump, and the time will be +1, so here time will be equals to 8, and this will be marked as true. That means it is visited now. So I will make this entry into the heap, and I will be making the entry for row number 2, column number 0, and the time is equals to 8. Now the next entry which is taken out will be 217. because 7 is the minimum time out of the 3 nodes. That means 8, 10 and 7, right? 7 is minimum. So 217 is taken out. From here I cannot make the up call. We can make the right call. If you make the right call, then this is a value 6. Here I have time equals to 7. So I can immediately make the jump in plus 1 time. So here time will be equals to 8 and it will be marked as true. Okay, so this has been visited. Now you can break this entire thing right now, or otherwise you can follow another strategy that whenever you pop out a node you can check. So I will follow the second strategy. Okay, now I will be inserting this node as well, which is 2, 2 and the time being 8. Now we cannot make a down call, it is out of bound. I cannot make the left call, it is already visited. So the next node which is taken out is, it can be 208, it can be 228. Let's take out the 208. So if you take out 208, I cannot make an up call, I cannot make a right call because both of them are visited. I cannot make down call, it is out of bound. Left call is also out of bound. So that is done. Next node taken out will be 228. And since this 22 is my target cell, so that is why I can say that I have reached here in the shortest possible time. That means the minimum possible time. And whatever is the time parameter, that will be our answer, which is 8. So I hope you were able to understand this dry run. In this case, we have taken visited array as an extra space, and we are maintaining the min heap as well as an extra space. So the space complexity will be order of nm and the time complexity will be nm times log nm. This log nm is coming due to the min heap that we are using, and these are the number of times we will most probably be taking out from the heap in the worst case, right? So nm log of nm. Now let's look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. After looking at this code, I will be explaining you the changes for the second problem as well. Now in this first problem, we are given the move time matrix and I have found the number of rows and columns. So I'll be taking the min heap, and after taking this I will be defining the start point, which will be row number 0, column number 0, and always the time will be 0. Now from here I will be pushing the first start point into the min heap. I will be taking a visited array as I had explained, and I will mark the first cell as visited, and then I will continue my process until the min heap becomes empty or I reach to the target cell. Okay, so whenever I take out a node, I will be checking if that node is belonging to the target cell, which is m-1 row and n-1 number column. If that is true, then I will be returning the time, okay, according to the dijkstra. Otherwise, if we have not reached to our target, I will try to make 4 directional call from the current node. So whatever is my row and column, to this I will use the direction array as I had explained and find out the new row, new column. I will always do the validity check, and if the call is valid, then I will check if it is visited or not visited, and if it is not visited and it is within the bound, then I will be making this call and pushing it into the min heap and marking it as visited, right? And at the end I will definitely be able to reach to my last cell. So these are the helper functions. This is the comparator which is trying to sort my heap according to the time, okay, increasing order. And then this is the bound check, which is valid, and this is my structure definition, and this is the direction array. I hope you were able to understand this. The second problem only had a single variation, that the cost will not be always addition of 1, but it will be alternating. The first jump will incur 1 cost, and the second jump will incur 2 cost, the third jump will incur 1 cost, and so on, right? So it will be alternating between 1 and 2. So for that reason, I will be maintaining one extra variable into my structure, which is the cost. This cost will define actually how much cost needs to be added. Okay, so while pushing into the heap only, I will be appending the required cost. So the entire code is same except for a few lines, like a couple of lines. You will see that I am always extracting the cost from the current node and I am finding out the next cost. So if the current cost incurred was 1 to reach to the current node, then the next cost will be 2. But if the current cost incurred was 2, then the next cost which will be added will be 1. So this is how we can alternate, right? This is the only change, otherwise the entire piece of code is same. So that is why I made both of them in the same video. I hope you were able to understand it. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of this programming videos. See you guys in the next video. Thank you.